All right. What was it? 80. 80.29. All right, let's see. No. That doesn't mean a damn thing about your work. What is it about 90% confidence interval? What does that mean? 90% of the intervals that people could make will actually contain the real mean. So how many intervals would I expect? What percentage of the intervals you guys made would I expect to not contain the real mean? 10%. So, and there's 26? I think I ended up with 25 up here, but there are 26 people, so I don't know. It's one person didn't want to put that up here, but I'll just deal with it. What's 10% of 25? 2.5. So I expect around 2.5 of the intervals to not contain the real mean. The 80.297 is the real mean of all of these, of the population. Are you guys with me? So I expect around 2.5 to not, and I got 1, 2, 3, 4, 5, 6 that didn't contain the real mean. So a little more than I expected, but still within that same realm. Do you guys, so this is, I really want you to realize what's happening. I could have several research teams that create their own confidence interval from the same population. And they're each trying to get a feel for where the sample mean is. Randomly, some of them will pick higher or lower. So like this one was too low. It didn't go high enough up. And then where's one that was too high? This one was too high. It's too damn high. Right? It was below the lowest one, the 80.297. It didn't contain it. So that, do you see that conclusion I make you right? We are 90% confident that the interval contains the true mean. Which means 10% of all intervals anybody could make will not contain the real mean. You guys semi with me on this a little bit? So what I'm saying is if I put an X through your interval, that doesn't mean a damn thing about the work you did. It is just an example of random chance. You randomly picked lower or higher numbers on average, so your interval was too far away from the real mean to contain it. I'm so hopeful somebody got some out of this. All right. Okay. This is beautiful. I love it, but oh well. All right. So, anything about T-scores, confidence intervals, please let them be one of the almost nicer. I know it's still kind of new, but normally the only work I have to do is figure out what the Z or T-score is. Sometimes I will have to figure out my own X bar and S, but I just let you do that in the calculator now, right? Like a nice guy. Unlike that test 1 where I made you make the tables. Okay. So, what we're about to get into, we're going to leave that behind. We're going to get into this next chapter because we're crazy people. So, all right. I'm going to take this away. I've got it recorded for myself for later. You guys see, are any of these the same? No. Because we each picked 20 different numbers. They all came from the same population. Right?
Wait, those are the same. Number 8 and 16.
Which ones?
8 and 16.
Ah, neat. There's one that's the same. So somebody picked. Okay. If you worked as a team, I should have told you just put it up here once, but oh well. All right. But what this means in real life, I normally don't know what the population is. So the best thing I can give somebody is an estimate based on what I saw. And we see that randomly sometimes I could get something that's not quite right. That doesn't mean anything's wrong with the math. It doesn't mean it's not useful. It's just the most truthful math. Life is uncertain. This math is uncertain. Hey, doesn't mean it's not useful. I don't want my brother being my doctor and saying, 50-50 chance you'll live, dude. Oh, shit. I want somebody who knows some statistics. 95% chance you'll live. Okay, I wish it was 100, but that's better than 50. Get the hell out of here, Dr. Jim. Right? Yeah, Jim, I still talk about you, buddy. He still doesn't believe. Anyway, all right. So, what we're going to get into now, real quick, before we get into this, if like men had an average between, like this was the confidence interval for men's averages, right? And women had an average interval from here to here. You guys with me? Let's just say. Is this evidence that the actual population means of men and women are different? So real quick, how did I construct these? I took a sample of what was this, men, and a standard deviation of men. I took a sample of women and a standard deviation for women. You guys with me? Is this evidence that the mean of all men and women, that those means are different? Yes. Why is it evidence that they're different? Because the intervals do not overlap. Right? If these are 95% confidence intervals, what's the chances I'm wrong about that? 5% chance. And that's better than normal for me. Shit, 5% chance I'm wrong? Damn, I can live with that shit. But there's always a chance I'm wrong because I'm basing things on samples. Maybe. So that is one of the most immediate things that you can do with confidence intervals is test a claim. You guys see it? So my claim was, oh yeah, men and women have the same average grade in statistics. And I take a sample of men and a sample of women and I see this, that is evidence their claim is wrong. You guys with me? Do you guys get that? So what would not be evidence that they're wrong? If I do this, is that evidence that I'm wrong? I just said it wasn't, so no. You guys, could it be the same? Could the means be the same? Yes. And what kind of mean do I mean? The population mean. That's the thing I don't know. So could the population mean be the same according to what I saw? Yeah, because they overlap. This guy's mean could be 80.2 and this guy's mean could be 80.2. Yes? I like it. But is that evidence that they are equal? No. I don't know what the shit they are. Okay, maybe. But that is evidence. That is not enough evidence that they are different, because this allows for them to be the same. Okay, maybe. All right. All right, so confidence intervals, though, are not strong enough to really test a claim. They are pretty quick to create, so I can get a rough feel for things. To actually directly test a claim, we use something called hypothesis testing. So I know you guys know the word hypothesis, right? Yes? No? You guys know the word hypothesis? Yes, a little bit? It's not hypotenuse or hippopotamus. Hypothesis testing. So I want to test a claim, basically, is another way to say that. So for example, if I claimed, let me see, use a less, all right, if I claimed that there's this island where the average height of all the people is over 7 foot tall. You guys with me? So I claimed to a friend of mine, oh yeah, there's this island where the average height of all the people there is over 7 foot. Are you guys with me? I haven't really said much yet, but you guys are like, just go, yes, Jeff, you've not said much yet, I'm with you. We go to that island, get off the plane, right? And the first 20 people I see are 5 foot tall. Is that proof that he's wrong?
No.
No. Maybe everybody who works at the airport is short for some reason. Like it's a requirement because they didn't make the doors tall enough or something. Right? You guys kind of with me? But is it evidence that he's wrong? Is it evidence? Evidence. All right. Somebody claims that everybody over in that, or the average height of the people in the room next door is over 7 foot. I see 20 people come out the room, and they're all 5 foot tall. How do you feel about his claim? You guys understand what's happening? So the dude claims the average height of the people in the room next door is over 7 foot. 20 people come out the room. They are 5 foot tall. How do you feel about his claim? Is he full of shit, or does he have a valid point? I'm not saying proof. Does everybody understand the difference between evidence and proof? Right? Evidence is something that points to something. Proof is something that says, shit, this is the way it is. So please understand, that is total evidence that he is wrong. Right? I'm like, if it's true, if the average height is over 7 foot tall, then any sample of people I see should be at least close to 7 foot tall, right? Oh man, are you guys all right? You guys, oh man, you look bummed out and shit. I don't know what you guys, what are you guys thinking about? Are you worried about what we're about to get into? Have you guys heard things about hypothesis testing, or are you just cussing out your former self in your head, like, why the hell did you sign up for 7 a.m. SAS class? Past me, what the shit? All right, well, I can't even, all right, screw it. I'm going to stop trying to find out directly what's going on. As long as none of you actually try to hurt me. All right, so somebody is going to have a claim. So, for example, I claim that my toothpaste makes your teeth whiter. How would I go about testing that claim? Or let's do it a little bit more direct. Let's say that there's a drug. I claim that it makes your headache go away faster. Right? I call it Stats Tylenol for statistics students to make that headache go away that Jeff gives. How would I test that? You know the fundamentals of this. I know you do. How would I go about trying to test a claim about a new drug? I want a new drug. Take a sample of people. Just one sample?
No, you have to have like a control.
At least 2 samples, right? Right. You want one group of people that actually get, I'm shoving this guy's mouth. You want one group to get your new drug, and at least one other group that gets a placebo. Now, normally you would have a third group that don't get shit. But let's not worry about that. Let's just focus on these two, right? And what would you want to see if you're the one that, if we all together created this drug in here, right? I'm not saying we're going to set up a lab in here and all that kind of shit. It's not going to be a Breaking Bad moment, but that'll be the wrong kind of drug. If we created this drug, what do we want to see happen? The group of people that took our drug and the group of people that took the placebo, or the old drug, let's say, not even a placebo, the other drug, the Tylenol or whatever else we're comparing names. What do we want to see happen?
Our drug works faster.
Our drug works faster. But what does faster mean? Remember, these are samples of people, right? Does everybody react to drugs the same? No. So not only does our drug have to work faster, it's got to work faster enough to be evidence. So if our drug took 10 minutes to take their headache away, and their drug took 10 minutes and 5 seconds, Did our drug work faster for our sample? Did it? Yes, it did. 10 minutes versus 10 minutes and 5 seconds. You guys with me? On average, amongst all the people. Is that strong evidence that our drug works faster? No, it's barely less. Right? Do you guys?
No.
Yes? I couldn't understand what you were saying. All right. So, everything, I know I said this already with confidence intervals, but this is the real. Hypothesis tests take just about every freaking thing we've learned so far and puts it into a form that's useful. So the main idea behind testing a claim is not only does it have to look like your claim is right, it's got to be far enough away from what you're fighting against. So we're fighting against our drug is the same as the old drug. So not only does our drug have to work faster, it's got to work faster enough to be evidence. It's got to be far away enough from the other drug's time to be evidence, to be real evidence that there's something else. If I'm only 5 seconds faster or something, that probably isn't good enough evidence. Now, what is it kind of built on? Whatever the standard deviation is. That's going to help me figure out how far away things are. We know that shit. We use standard deviations to tell us how far away we are. All right. So, let's go to this. Let's go with this example. So we make a new drug. Oh God. How are you working? Oh, that's better. New drug versus the old drug. And our claim is that our drug works faster. And let's say the old drug takes 11 minutes. You guys, all right, let me just stop right there. You guys all cool with that? The old drug, on average, takes 11 minutes to work. We say our drug is faster. Clinically proven, that's what that means. If it passes the test, then we can make a commercial say, it's clinically proven. We don't have to say it like that, but. So can somebody put this into mathish for me? Our claim is that our drug, the average time our drug takes to work is faster. So the average would be mu. Our claim is, how does that compare to 11 minutes? Mu is what of 11? Mu is, I love you guys. If it was greater, then would that be faster? All right. Faster means less time. So this is our claim in mathish. Right, here it is in English, here it is in mathish. I like it. So anytime there's a claim, there kind of has to inherently be an opposite stance. So if somebody says, I can score better than you, then the thing you're fighting against is, no, you're going to score the same or worse than me. And that's the opposite stance. So what's the opposite of our claim? What's the opposite of this?
11 is greater than.
Well, that's what that says.
11 is less than.
I love you guys so much. Mu less than 11. The opposite is?
Mu is greater than 11.
Or?
Equal to.
There we go. Holy shit. Okay. So I always think about this like two old men in a coffee shop, right? And I'm getting closer and closer to that for myself. Someday I'm going to be one of those little men in a coffee shop. Oh, yeah, the president don't know shit. Have you all seen these people, right? And one guy is like, no, you're right. And the other guy's like, I'm right. Screw you. So I was thinking about these two hypotheses as being these little men with opposite ideas. No? Yes? So, that's just me, I guess. One of these is going to be called the null hypothesis. Oh, shit. And the other one's going to be called the alternate hypothesis. Now, let me ask you this. Which one of these includes the possibility that it's equal to? obviously the one that's got the equal sign. Let me see what you guys think about this. Can I ever take a sample and prove that the population mean equals a number using a sample? So if I think the population mean age at Grossmont is 27, can I take a sample and prove that the population mean age is 27? Can I? No. Can I take a sample and show evidence that the population age is less than 27? Yes, if I take a sample, a good big sample of Grossmont students, and the average comes out to be 24, that could very well be evidence that it's less than 27. So the alternate hypothesis is always going to be the statement that I could actually show evidence for. The null is always going to be the one that I couldn't possibly show evidence for. So what does that boil down to? The null always has to have the equal sign, and the alternate can't. That's it. So where does this one go? Does it go in for the null or the alternate? Yeah, it doesn't have an equal sign, so the alternate, and this is what, I think this book uses H1, which is okay. I think other books use HA, which kind of makes a little more sense, but oh well. So our alternate hypothesis is that the mean is greater than 11. What's our null hypothesis? It's the other little old dude. Sorry, what did I just put down? Well, that's not there. And then the null is this guy. So whatever the claim is, you just put it in the right place. And then what's the other one going to be? The opposite. So if your claim doesn't have an equal sign, it goes here for the high. If your claim has an equal sign, it goes here for the ho. Yes. So we have the highs and the ho's. Okay, I like it. I always like to say, if I offend you, just wait a few minutes, I'll do it again. But it is, how can you escape that? I got to say it. All right. So far all we got is, if I have a claim about something, that inherently means I'm fighting against something else. That's what a claim means. I claim this. Well, there must be some idea that I'm fighting against in a sense, right? So that's all these two are, is what are the two positions that somebody could hold? They could agree with me or not. Okay, I like it. That's step one of 5 steps. There were 8 steps when I learned it, so I've condensed it to 5 steps. You're welcome. So this is step 1. Let's say that somebody give me a good sample size for our test. What's a good sample size for us to give this new drug to?
130 people.
130. I love it. So we give this drug to 130 people. Right? And we find the sample mean is 10.1, and the sample standard deviation is 3.5 or whatever. These don't matter at the moment. Why am I allowed to do anything in this problem? Why could I calculate z-scores and give percentages? Why am I allowed to do anything? No, that doesn't have anything to do with it. Why am I allowed to use the z-score chart if I need to? N's bigger than 30. Yeah. So the second step, first step is, what the hell are you talking about? This just sets up what we're talking about. Who are my 2 little old men? The second step is, all right, I know what you want to talk about. What are you going to be able to use to talk about it? T or Z? So we know we can do something, n greater than 30, so I can do something. What's that something? What can I use? T-scores. So I really wanted to make sense. Each of these steps is kind of like should naturally happen, but now we're just making sort of a recipe. What the shit are you talking about? What are you going to use to talk about it? Right? And then the third and fourth steps. All right, let me see. Let me back up for a second. Can you guys tell me, what's your gut tell you? Which one of these can I prove again? Can I not prove, but show good evidence for? Which one is it possible to show evidence for? This one. How many tail test is this then? So what do I want to find? If I have made this new drug, where do I want my sample of people to show up on that picture? Yeah, one direction, not the band, right? So it's a one-tail test, which is another reason why the T-score chart has one tail and two tail. It goes right along with this. This is a one-tail test because to show evidence for this, my sample has to show up far enough below 11. So it's a one-tail test. And let me say this. All right. There's a little symbol that I always wish I remembered to introduce earlier. But there's a little symbol for the amount of area in the tail of something. So, for example, if I had a 98% confidence interval, what percentage is in the tails? 2%. The symbol for the amount of area in the tails, or in this case, one tail, is a little Greek symbol called alpha. So if I said alpha, there's alpha, little fish dude. Goldfish dude, there he is. All right. It's got no mouth, but you know, oh well. Take the animal out. So if I said alpha was 0.01, that means that there would be 1% in this tail. So again, I want to come back. I think I'm going to transition to this handout I got in a minute. I just wanted to get enough of these sort of talked about in general, and then I got another specific example with everything fleshed out. Everybody cool with the idea that not only does my sample have to be below 11, it's got to be really below 11 to be strong evidence. Why? Because I'm only ever working with samples. So to be evidence that the whole population is actually less, it's got to be far enough below it. What the shit is far enough? Well, now I have a way. They got to tell me what this is, because that tells me how far away I've got to be. How many tail tests? 1. Alpha's 0.01. This is a little shitty, but I will. What's my degrees of freedom? 129. One tail, 0.01. Let's go ahead and make this degrees of freedom 100 because it doesn't go to 129, right? So I always kind of like, can you guys see on your T-score chart what far enough away is? Where'd it go? There you were. One tail tests, one tail. What's the area in the tail? 0.01. You gotta kind of love that the symbol for it is a fish with the tail on. So that's the area in the tail. 0.01. So this column I'm looking at, right? And degrees of freedom, we're gonna say 100 because we don't have 129. So this is what tells me how far away my sample has to be to show evidence that the population is smaller. It would be less than 11 minutes. So is it 2.364? There's something not quite right about that. Because this is negative. Right? The T-score chart, notice how it doesn't have any negatives on it, does it? Of course not. We're the humans. We got to know if that's negative or positive, what side we're on. I love you guys so much. So what I would do now, what I don't think I'm going to do, I've got a nice little handout. The fourth step would be take a sample and see where it falls. If my sample fell here, That's not enough evidence. Is it far enough away? No. So I couldn't say that this is right. I didn't find evidence for this then. It's not far enough down. If my sample showed up here, that's evidence. Because, real quick, here's the real thing behind this. This is the beautiful thing about hypothesis tests. Do you guys notice when I drew that picture, what did I put in the middle? When I drew the picture, what did I put in the middle? 11. So the thing about hypothesis tests is, assuming our drug is 11 minutes average also. Stay with me. If I assume that our drug has an 11-minute average also, and I get a sample here, what's the probability, if that's in the right place, if that mean is in the right place, what's the probability I get a sample in here? We know exactly what that is. 1%. So what's more likely? It's only a 1, if 11 is the right mean for my drug, and I get a sample in there, and that only happens 1% of the frickin' time, what's more likely? That I just happened to get a sample that was there, or that the mean is actually lower? What's more likely is the mean is lower. If the picture was moved over, then the thing I got would make more sense. So basically we're saying, all right, assuming it is 11, look what we just did. We just did something insane, right? So if you said, I don't think there's I can't get away from the height thing. But if you're like, what do I want to say? Yeah. So if the guy says 7 foot tall, average 7 foot tall, and I see 20 people that are 5 foot tall, how likely is it that he's right? There's still a chance he's right. You with me? But how likely is it that he's right? Very small. What I've seen is evidence against what he's saying. So what this is doing is it's making very specific about how far away do you have to be to show evidence that it's not, in this case, 11. So let me give you this. We'll talk a little bit about it, and then we'll head out.